Hey everybody, and welcome to our next video about factoring. Today we're going to talk about factoring some special cases, specifically the difference of squares and the perfect square trinomial. Let's get right to it. The difference of squares, let me show you what would happen if I were to FOIL something that we're going to factor here in just a moment. If I have x minus 3 times x plus 3, check out what happens. I get x squared plus 3x minus 3x minus 9. If I look at my middle terms, I have 3x minus 3x. So they end up canceling out. I'm left with just x squared minus 9. Now, if we see a difference of two perfect squares, so check it out here, x squared, that's a perfect square. 9 is a perfect square. If I see the difference of two perfect squares, I can jump right to this situation here. Let's look at another example. What if I have x squared minus 16? I can factor that to be x plus 4, x minus 4. I took the square root of the first, or square root of x squared, and I put it in the first place. The square root of the second term, and put it in the second place. That's our difference of squares. Okay? Now a perfect square trinomial would be something like this. We'll start by expanding. So let's say I have x plus 5. Alright? Squared. I'll end up with x squared plus 5x plus 5x plus 25. Okay? When I combine my like terms, I'm with x squared plus 10x plus 25. Okay? Now, what you want to check, right, that if I take the square root of the first and the square root of the last, okay, if I multiply these and double it, and I get the middle term, then I can go ahead and factor this as a perfect square trinomial. Let me show you what I mean. Okay, if I'm given x squared plus 8x plus 16, okay, take the square root of the first, it's x, square root of the last, that's 4. If I multiply these two together and double it, I end up with 8x. So that means that this is equal to x plus 4 squared. Okay, let's look at a few more examples and see if it becomes a little bit more clear. So these are all examples of difference of squares, right? I've got two terms. They are both perfect squares. So watch this. Take the square root of the first, that's x. Take the square root of the last, that's 6. And now I alternate my signs. Okay? If I were to FOIL, I would end up with x squared minus 36. Okay? Check out the next example here. 4x squared is still a perfect square. If I take the square root, I end up with 2x. So I put that in the front of both of my quantities. I take the square root of 25 and I get 5. Now I alternate my signs. Okay, last one. Square root of x squared is x. Square root of 9 is 3. Now I alternate my signs. Alright, now you go ahead and pause the video and you try the next few. We should have found that I have 4m plus 13, 4m minus 13. For the next question, it was x plus 11 and x minus 11. And then last, we've got x plus 4 and x minus 4. There you have it. There's the difference of squares. It's one of your special cases. Looking at the next examples, these are all perfect square trinomials. Perfect square trinomials. So here we go. If I take the square root of the front, that's x. If I take the square root of the back, that's 8. If I multiply these two together and double it, I get 16x. So this is in fact a perfect square trinomial. This will be x minus 8 squared. Now you might be wondering why minus, because that's the sign of the middle term. The sign of the middle term carries right on down. All right, let's look at the next one here. Take the square root of the front and I get 3x. Take the square root of the back and I get 5. If I multiply these two together, I get 15 and double it. It gives me 30. So that means now that this is 3x plus 5 squared. Again, sign of that middle term carries right on down. Okay, last one. Take the square root, it's 2x, and take the square root of the back. That is 9. Okay, if I multiply these two together, I get 18 and then double it. Ooh, I do not get negative 30x. This is not an example of a perfect square trinomial. This one will not factor. This one is what we call prime. All right. Now you give it a shot. Let's try some perfect square trinomials. Oops, sorry about that. All right. Let's go ahead and check those answers. We should have x plus 2 squared. Let's verify that this is actually a perfect square trinomial. 6x and 5. When I multiply 6 and 5, I get 30. Double it is 60. So I can write this as 6x minus 5 squared. Again, the sign of the middle comes straight down. Last, this is 4x and this is 3. If I multiply these together, I get 12 and double it, I get 24. So this is now 4x plus 3 squared. Well, there you have it, folks. There's our special cases, the difference of squares and the perfect square trinomials. You've now got enough information to hopefully finish up that factoring packet. That's all for now.